Okay, I'm going to go ahead and pick up to where I left off on the last video. So now I'm going to add 4 times the quantity x minus 3 cubed, and I'll go ahead and add one more term plus 4 times the quantity x minus 3, and that's to the 4th power. So that gives me the first 5 terms of that power series. So I'm going to go ahead and enter that in. So I have something on my screen that is a little hard for me to see. So one thing that I want to do is, let's try a zoom fit and see where this takes us. We are going to change this in a minute anyway, so it's not anything that we have to worry too much about right now. So we have our function being graphed on the screen. As a follow-up question, one of the things that we want to know is, did we get the right interval of convergence? Well, in order for us to find that out, we have to take our power series and basically figure out what that function is going to look like. So we know that we can write this as 4 x minus 3 to the n power. We learned that base is something like this. So if I wanted to, and that is our series for, I'm going to slide over, x to the n. So that's not what we have. We have x minus 3 to the n. So in order to find a series for x minus 3, like we have circled here, all I got to do is replace each and every x in base with x minus 3. So I'm going to say 1 over 1 minus x minus 3 equals 1 plus x minus 3 plus x minus 3 squared plus dot dot dot. So that gives us this series. So I can simplify a little bit, or I could leave it alone. I'm just going to leave it alone. So then to finally get the series that we're looking for, I take our answer and I multiply it by 4. And that's what we're looking at on the calculator. So I have the equation on the right in F1. So we need to take this equation on the left and put it into F2. So we're going to put in 4 over 1 minus x minus 3. And of course, I'm not going to stop you from simplifying this. But for right now, I want to go back to my calculator, and I'm going to hit the tab button, and I'm going to put in that expression. My lights went off. Hopefully you can see, and you can't. I'm going to go turn the lights on. Hang on. Okay, I'm back. So I'm going to go ahead. We can see now. That's good. So I'm going to divide this by the quantity 1 minus the quantity x minus 3. And then I'm going to close both those parentheses. So I'm going to go ahead and graph that function as well. And now I'm going to go and change my window. So we found that our interval of convergence went from 2 to 4. So I'm going to go ahead and let's graph this and see where we're at. So I have 2 functions, f1 and f2. And boy, I just can't see anything. So I'm going to go ahead and zoom fit. And let's see if that helps me. And I'm going to go ahead and try to manually zoom in on this. So I'm going to go ahead and I am going to make this go from about -1 to 50. Let's see how we do. Okay, that was really a pretty good guess. So I can see on my interval of convergence that here's my function in red and the blue is the power series. On my interval of convergence, we're doing pretty good. Notice how my function and my power series, they converge in the middle. Now as we get towards the end, they start to separate. What would bring those closer together is if we continued to add terms to our power series. So that completes our summary frame. We've proved graphically that we are on the interval of convergence. Although, just to convince you more, let's go ahead and let's change those window settings on X. Let's open it up from 0 to 8. Now that I'm making the interval bigger, you'll see that on the ends, the left and the right end, the function and the power series are further apart. So this is a great indicator that outside the interval of convergence, that the function and the power series, they're not similar. But if I am on the interval of convergence, which we calculated to be 2 to 4, that the power series and the function represent each other pretty well.